I forgot to film the intro to this video, so let's get into the guided tour. Starting with this Super Guppy based on the 1950s Boeing 377 Stratocruiser, which itself was based on the B-29 Superfortress bomber that dropped the 2 atomic bombs on Japan. One actually remains in service with NASA to this day and is used to carry extra large items. In fact, this aircraft is the only one capable of carrying the completed third stage of the Saturn V rocket, which, as you can see from my footage from Houston, is pretty massive. While the first Super Guppy was heavily based on the 377 and shared the lower fuselage, this later model was heavily modified and only shared the cockpit, the wings, tail and the main landing gear. There's quite a bundle of attachments here at the hinge, which would obviously have to all be very flexible to allow for the door to swing open. This was before the era of fly-by-wire, so flight control cables connecting the cockpit controls to the control surfaces would need to pass through the door, but they are so finely tuned and there's no flexibility in them. So they would actually have to disconnect and reconnect every cable after every door swing, which was an incredibly complicated job, but also very important. You may recall the story of the Air Astana flight 1388, which almost resulted in a crash after engineers installed the aileron cables incorrectly, reversing the controls. I can understand why every other large transporter since then doesn't move the cockpit away from the rest of the fuselage when the door opens. We'll look more at this once we get down on the ground level. This here is a prototype Concorde and never flew paying customers. It's hard to believe that Concorde first flew in 1969, as it really does not look like a 50-year-old aircraft. We'll come back to this when I show you inside the interior. Now my primary focus is airplanes, because I don't really know a great deal about helicopters, but briefly, this is an Aérospatiale Gazelle, designed by the Brits and the French together. Of interest, it was the first helicopter to feature a drag-reducing fenestron tail with an aerodynamic cover for the tail rotor. This is now commonplace on modern choppers. Now I'll include a link to the detailed guided tour video around and inside this aircraft below, but just briefly, this is the Airbus A300, and while it's not the original first one, it has been painted in the livery of the prototype. Now I can't understate the significance of this aircraft, as it wasn't just the first Airbus, which was a huge gamble but ultimately succeeded and led to the creation of the brilliant and hugely successful Airbus company now, but it was also the first wide-body twin-engine airliner, which we now know is the norm. Prior to this, any large airliner had 3 or 4 engines. Jim Austin, the Boeing VP in 1977, was quoted as saying, "It's a typical government airplane. They'll build a dozen or so, and then they'll go out of business." And he couldn't have been more wrong. In a very clever deal, Airbus gave 4 A300s to Eastern Airlines in the United States for 6 months at no cost, because they were struggling to get interest from the American airlines. The airline itself fell in love with it, and subsequently ordered 23 more, and the rest is history. Another interesting fact was that they intentionally decided to design the aircraft in English and use imperial measurements, because again the United States was going to be the target market. And they also wanted to avoid the problems that we saw with Concorde, where French and British engineers misunderstood each other. Here we are back at the Super Guppy again. In front of it is this scale model of the aircraft that replaced it, based on the A300 that we just looked at, and it's the A300-600 ST Beluga, which I'm sure Airbus felt much more comfortable using than something from their direct competitor Boeing. But back to the Boeing Super Guppy that we have here. While this was a special development for NASA, when Airbus realized that land transport for the A300 components to the final assembly point was not realistic, they actually bought several of these. In fact, more were built under license in France as Airbus production increased. They installed the nose landing gear from a 707 and rotated it 180 degrees, which lowered the nose slightly, thus easing the loading process. And by the way, here's a military version of the 377, the C-97, on display at Pima, and you can just make out the similar windscreen. It was fitted with 4 Allison 501 turboprops, each developing 4,680 horsepower. These were a considerable upgrade from the radial piston engines used on the donating aircraft. Let's jump back and check out this MiG-15, which was the first successful Soviet jet fighter and was designed with the help of old German research on swept wings found at the end of World War II. It has a central air intake, but if you look inside, you'll see that the air is ducted to the sides to allow space for the pilot to sit. It was considerably superior to the straight-wing fighters such as the Meteor at the time, and the Americans rushed the F-86 Sabre to compete with it. It was the most produced jet aircraft ever, with over 18,000 built in the USSR and their allied countries. Moving on, we have the Dassault Mirage III-C, which was also built under license in Australia. It was powered by a single ATAR 9B3 turbojet engine with an afterburner, but if you deleted the cannons, leaving it with only missiles, they could install a SERP rocket booster for additional thrust. It had a delta wing which gave it brilliant high-speed performance. In fact, it had a top speed of Mach 2.2 up to a ceiling of 54,000 feet, but not a great deal of low-speed lift. In fact, the joke was that if an engine failed at low speed, it had the gliding characteristics of a well-trimmed brick, and a large proportion of them flying in the RAAF did actually crash at some stage of their career. And a final look at the Super Guppy, and this actual aircraft flew up until 1996. You'll notice that I've skipped a few aircraft in the foreground, and that's just to save time. Apologies if there's something that you really wanted to see, although I wanted to save space on my hard drive to properly look at the A380 later in the video. The next fighter is a Franco-British SEPECAT Jaguar A, which was a close air support aircraft but later evolved into a nuclear delivery platform for the Brits, the French and the Indians. It was the main strike and attack aircraft for the French Air Force up until 2005, when it was replaced by the Dassault Rafale, and the Typhoon replaced it in the British RAF. This was especially impressive considering it was originally designed as an advanced trainer, and it continued in active service in Oman until 2014. Spinning around, and we have the American Lockheed F-104G Starfighter in the German Luftwaffe livery. It was the first interceptor capable of reaching Mach 2 and an altitude of 100,000 feet. The USAF actually dropped it shortly after it entered service, but it remained with European allies for many years. In fact, the Italians continued using it until 2004. This is a Saab Draken J35, which had a novel double delta wing with one part swept at 80 degrees and the other part at 57 degrees. This allowed for good high-speed performance, but also good low-speed lift, which the Mirage, with the standard single delta wing, did not have, hence the glide capabilities of a brick Comet. It was powered by a single Volvo RM6BC turbojet, which was a license-built Rolls-Royce Avon, and powered it up to a top speed of Mach 2 and a service ceiling of 65,500 feet. Also, as we move around the back, you get a better view of the double delta wing. And while we've seen it many times since then, including on the likes of the Space Shuttle Orbiter, it was groundbreaking in 1955 when this first flew. It was retired from the Austrian Air Force in 2005. Of interest, this was the first aircraft to use the Cobra maneuver. They accidentally discovered that if they pulled back on the stick, lifting the angle of attack dramatically, the large wing would act as a massive air brake, dramatically slowing their speed, resulting in the pursuing enemy fighters overshooting past them. Then they'd be behind them and could line them up with a bang. Here's another American jet, the Vought F-8 Crusader, which was a single-engined, carrier-based air superiority jet used by the American and French navies. It was introduced in 1955 and was considered to be the last fighter where guns were considered to be the primary weapon, and that missiles would take over. In fact, the later F-4 Phantom II was designed without guns, but they were sorely missed during the Vietnam War, and a gun pod was rushed back in. Even now, with the likes of the F-22 and the F-35, those two have inbuilt guns. As you can see, this was also fitted with missiles. The wings would fold up as to reduce storage space on the carrier, and it was capable of in-flight refueling with this probe here, and it was fitted with slats and flaps to improve low-speed lift, and it's not something you see on most fighters. Spinning around, we have a really fascinating size comparison. This here is the air intake from an Airbus A380, and it's fascinating to compare the size with the CFM56 behind it, which is the standard engine on the A320 CEO and the Boeing 737. We will trundle over to the relatively tiny CFM56 itself. What's interesting with these high bypass turbofans is that much of the thrust is generated by air moved by the large fan blades at the front rather than that which comes from the exhaust of the hot core itself. Looking back towards the front, you can see how much of the fan blades stick out to the sides of the hot core, thus blowing air that completely bypasses it and actually helps cool the engine itself, as well as contributing to the thrust. And turning around, we continue the tour by looking at the tail end of the Concorde. One of the changes from prototype to the production version was a much larger tail cone, which actually had fuel tanks installed in it. To help trim the aircraft, they'd usually have to create aerodynamic tabs, but that would obviously affect the overall efficiency by increasing the drag, so they instead trimmed it by moving fuel fore and aft. I explain more of this in my guided tour video through a Concorde at Duxford, where I filmed inside the cabin as well as the cockpit. We get a brief look at those Rolls-Royce Snecma Olympus 593 turbojet engines, which interestingly are upgraded versions of the Avro Vulcan engine with an addition of an afterburner. But unlike the Tupolev Tu-144, Concorde could sustain supersonic flight without the afterburner active, hence better fuel economy and a longer range. What's also interesting is that they used turbojet engines, when everyone else at the time was using the newer and more efficient and quieter turbofans. Apparently this was because the turbojets were considerably smaller, thus reducing drag, which would have been an even bigger problem if there was ever an engine failure in flight. Of interest, one of the Tu-144's engines was a turbofan, and they were considerably larger. In fact, I directly compared the two in my Tu-144 video filmed in Germany, and that's on my channel. And I suspect this contributed to the much poorer efficiency, even in the non-afterburning model Tu-144. Let's jump back up on the upper level and walk inside this incredible piece of Anglo-French engineering. Now we all know it wasn't an economic success, but it's great that it's still built, and there are many other worse things that taxpayer money could have been spent on. Immediately on the left is the cockpit, which unfortunately is off limits in this museum, but again check out my other Concorde specific tour video at Duxford where I show you inside the cockpit in more detail. As I mentioned earlier, this aircraft was a prototype and never carried paying customers, so the interior is full of test equipment. Data collected from sensors all over the aircraft would be stored on good old-fashioned tape for further analysis after they landed. It really is impressive engineering to think that it was all designed with such low levels of technology. Computer-aided design has obviously revolutionized the whole developmental process. Even though this was called a production aircraft, as evidenced by the larger tail cone, it never went into service as the final versions were different yet again. This specific aircraft itself first flew in December 1973 and took part in 423 flights, where 247 of them included supersonic sectors, and it flew for a total of 909 hours, so it really is an extremely young airframe. It last flew in 1985. Towards the back are some rather comfy looking chairs, and then we spin around and head out over the massive ogival delta wing, and across the pathway is the A300, which I'll show you through in a separate video, with a link to that in the video description below. Now let's head outside and into this freezing and rainy Toulouse weather, although I'm grateful that I managed to capture this now as the rain only got heavier later in the day. So I just mentioned the A300 twin-engine widebody earlier, which was developed into the A310, the A330, and of course this aircraft, the A340. This was actually a bit of a miscalculation from Airbus, who wanted a long-haul version that could fly across oceans. The idea was that you needed 3 or 4 engines to safely fly so far from land, but during the time that the planning and then the delivery of the A340 happened, engine reliability improved and the Boeing 777 arrived. It only had 2 engines, it could safely fly long distances over water, and used a lot less fuel. This specific aircraft was the A340-600 model, which first flew in 2001. It had an upgraded wing and was longer than the original A340s. In fact, it was the longest airliner in the world prior to the arrival of the 747-8. In addition to the extra engines, it also had an additional landing gear between the 2 main ones shared with the A330. Production ceased in 2012 after only 380 were built. Now the primary competitor, the Boeing 777, remains in production, and so far over 1,700 have been built. Although it's only fair to recognise that the A340 does share a lot with the A330, which there have been over 1,500 made, so the production costs would have been spread over that platform as well. Moving on is the A320 prototype, which of interest is where the A340 got its cockpit from. This pioneered the use of fly-by-wire and side-stick controls. In fact, the original A300 inside the museum had yokes similar to what is used by Boeing now. This was the first Airbus narrow-body airliner, and over 10,000 have been assembled in plants here in Toulouse, Hamburg, Alabama, and in China. This has since evolved into the Neo, or the new engine option family, with the most obvious changes are larger and more efficient engines, larger winglets, and black paint around the windscreens, which does look pretty good. And going from the small Airbus, we head in the opposite direction again, looking at the biggest, the incredible Airbus A380-800. I know that these images just don't do it justice, but it is truly massive next to the A320. In fact, the A320's fuselage looks like it's about the same diameter as the A380's engines. On the topic of numbers, it's certified to carry up to 853 people, and the weight of the external paint, which is just the top coat and the primer, is over half a ton. The span of the horizontal stabilizer is 30.4 meters, which is just a little bit less than the span of the A320's total wings at 34.9 meters, which I'll swing back around and show you in case you've forgotten how tiny the A320 now looks. And speaking about the main wings, and back to the A380, they flex upwards by over 4 meters during takeoff, which I'll mention more once we get inside. It has an incredibly complicated landing gear with 22 separate wheels, and each of the 6 wheel body gears can carry 260 tons. And while that's shared over several of them, remember that it may not always land perfectly flat, and there's extra momentum as the aircraft descends as well. The massive wing is 845 square meters, generating a huge amount of lift, thus allowing it to have the same approach speed as the much smaller A320, thus reducing noise. In fact, Airbus claim that it needs 300 meters less runway length for landing and takeoff than competing large aircraft, which I suspect is the Boeing 747, although the press release doesn't specify. Of interest, these wings were designed to handle up to 650 tons to allow for larger and heavier variants, although none of these eventuated. It's powered by 4 massive turbofan engines with 2 options, the Rolls-Royce Trent 900 or the Engine Alliance GP 7200. The 116-inch diameter fan blades suck in over 1.25 tons of air every second, and having been fortunate enough to fly on the A380 several times, they provide for an incredibly quiet takeoff. Being such a massive aircraft with a max takeoff weight of 560 tons, and for interest's sake, the A320's max takeoff weight is 172 tons, airports had to invest considerably. This includes stronger taxiways, and even to this day many airports have specific A380 taxi routes that they can't divert from. Taller aero bridges were also required to deliver passengers directly to the upper deck, unlike the 747 where they would be always delivered to the main deck and then have to move up the stairs on board. Now, just before we go inside the A380, let's quickly jump over to the ATR 72-600 twin-engine short-haul regional airliner, which was assembled here in Toulouse. ATR are a joint French-Italian group, and this aircraft first flew in 1988 and remains in production with over 1,000 assembled. Okay, so now let's head back to the incredible A380 and head inside. Here's a view of engine number 1 and 2, and I must admit that I always enjoy my final inspection of the aircraft that I'm boarding as I walk along the aero bridge, as long as I don't see any duct tape. Entering the main deck, and what's obvious is just how spacious it is, especially with all the seats removed. This was a prototype and never flew passengers, so the interior includes test equipment as well as marketing stuff for the airlines. Now turning left, we head towards the cockpit, and I love how they've removed some of the plastic coverings so that you can see what's behind them. On the wall you see the insulation as well as the air conditioning pipes. Now on the floor, they've added a glass so that you can see into the forward luggage compartment. Now this is all fly-by-wire, so there aren't any of those physical flight control cables that you will have seen on my guided tour video around the 747 in Australia or the first jumbo prototype in Seattle. Looking up here, we have the cockpit, which only requires a 2-person crew, although obviously there's usually more resting since this is a long-haul aircraft. What stands out is how incredibly spacious it is, which would no doubt contribute to the crew feeling a little fresher. The screens are all electronic as you would expect with a modern airliner. Immediately behind is the crew bunk, where they can get some sleep but also be very close to the cockpit so they can return quickly if required. Moving over towards door 1 right, we see more of the internal equipment, and then we'll make our way towards the back and look at some of the test equipment as well. In total, 254 were built, including 3 prototypes, with 119 of those flown by Emirates Airlines based in Dubai. This position here on the right is the Test Flight Engineer station, and I should clarify that there isn't a normal flight engineer on this aircraft, as it's modern and again there's only 2 flight crew required at any time. These people here monitor the thousands of parameters being recorded and would be alerted if anything was abnormal. It's all electronic, so they can look at any parameter they want to, and it's all recorded onto hard disks. It's interesting to compare this with the Concorde prototype that recorded everything onto kilometers of magnetic tape. These here are barrels where water and glycol would be added to simulate the weight of passengers and freight. During test flights, there would be 123 of these throughout the aircraft and could contain up to 330 litres of liquid. There would be 6 that would transfer between them to simulate changes in the centre of gravity during the flight. Moving over here, you have a view of the wing, and next to that is a camera. One of the requirements for certification is a static wing bend test. The deflection obtained on the A380 wing was 6.8 meters without damage to the structure. The wings are required to resist 150% of the maximum load. As well as simulating the weight, they would also simulate the electrical drain from the passengers as well. In fact, 80% of the electrical power consumed on an A380 during the flight is by passengers using lights, the in-flight entertainment, and playing around with the seats. Therefore, this would all have been simulated by burning up energy as well. Now, I must admit the ballast tanks made sense, but I would have never thought about simulating 500 people's TV screens, so I guess it's a good thing that I'm not testing this aircraft. Next up is more marketing displays for airlines and air shows to demonstrate what airlines could do inside their A380s, such as this high-end shop for expensive stuff that I'm not really interested in, so moving on, and up we go up the stairs. While the main deck was 6.5 meters wide, the upper deck is a little narrower at 5.8 meters, although as Airbus likes to remind you, it's still 1.8 meters wider than the upper deck in a 747. Here we are with a bit of a lounge concept, with Emirates and Qatar kinda used on their aircraft for first and business class passengers. Unlike the 747, which was only a single aisle narrow body on the upper deck, this was a proper wide body with 2 aisles up here, as you can see with these economy class seats. Moving into the next section are what they predicted future business class seats might look like, and in front of that was another bar with a very pink toilet. Being such a massive cabin means that it's split into 15 different climate control temperature zones, each of which can vary between 18 and 30 degrees Celsius. It really is a massive aircraft, as you can see that we are now almost getting towards the front of the upper deck, and in front of you are those stairs which lead down to the main deck where we started. Now I've gone back and exited from the upper deck, and people criticise the A380 because it wouldn't have broken even financially, but anyone who has flown on one of these would tell you that they are easily the most comfortable way to fly. Now we all love the 747, but this is decades more refined and comfortable. Now it's a great museum here, although one major criticism I have is that there is no cafeteria. I came here planning to eat lunch, as I did at every other museum that I visited on this trip, but by this time I was increasingly hungry and grumpy. Unfortunately, I only discovered the second Concorde and Caravelle on display as I left the museum, and because I was so hungry I didn't want to go back, so apologies that I didn't show you much around those. Please check out my channel for separate detailed videos through the A300, Concorde and many other interesting aircraft. If you enjoyed the video and want to see more museum tours, then please give it a thumbs up and comment below. Thank you very much for watching.